Dividing polynomials. We're going to cover two methods for dividing polynomials. The first method is if you're dividing by a monomial or one term. So example 1, all one fraction, which of course is nothing more than a division problem. So we have four terms, a polynomial of four terms in the numerator divided by a polynomial with one term in the denominator, monomial. So in order to perform this division, we begin by breaking up this one fraction into a bunch of smaller fractions. In other words, each term in the numerator will be rewritten into its own fraction. So four terms in the numerator. For this problem, we're going to rewrite it into four individual fractions. Just take each term in the numerator, 8x to the fifth, and put it over the denominator, negative 2x squared. Plus the next term in the numerator, 2x to the fourth, over that same denominator, negative 2x squared. Plus the third term, negative 6x cubed, over the same denominator, negative 2x squared, and the last term, negative 2x squared over negative 2x squared as well. Now all we do is simplify each individual fraction. The first one becomes 4x cubed. The second fraction simplifies to negative x squared. The third, positive 3x, and the last, just positive 1. So we perform the division. Our final simplified answer in standard form, 4x cubed minus x squared plus 3x plus 1. Example 2, dividing by a monomial. So in this case, we have three terms in the numerator, so we're going to divide up this fraction into three individual fractions. The first one, negative 14, x to the 8th, all over 7x, plus 21, x to the 6th, over 7x, and that last term, 7x to the 4th, over that same 7x. Simplify each fraction in this case. The first fraction becomes negative 2x to the 7th, plus 3x to the 5th, plus the final term, x cubed. So a final simplified answer in standard form as well. The next method for dividing polynomials is long division. We're going to use this method if we're dividing by two terms or a binomial. So in long division, by its name, I think it's a little lengthy, so give yourself plenty of room. Neatness and organization is going to be key to not making careless mistakes here. So we all know the division bar. The denominator, what we're dividing by, goes out in front, x minus 5 in this case. The numerator goes inside. But we have to make sure the numerator is written in standard form. And we also have to include a term for every descending degree all the way down to 0. So in our numerator, we have three terms. The first degree is 2. The second degree is 1. The third degree is 0. So we begin with a term of degree 2, x squared. That means the next term has to have a degree of 1, and it does. That's our x. And the last term must have a degree of 0. That's our negative 30. So nice neat columns here. Everything that goes in the first column will have a degree of 2. Everything that goes in the second column will have a degree of 1. Everything that goes in the third column will have a degree of 0. So in order to begin dividing, focus on the first term in the divisor, the x out in front, and ask yourself, what do you have to multiply x by in order to get x squared, the first term in the numerator? Well, of course, x times x gives us x squared, so we're going to write that x above the x column of degree 1. And then multiply by everything out in front. X times the x minus 5 gives us x squared minus 5x. We're going to subtract, making sure we distribute the subtraction to both of these columns. The first column here, x squared minus x squared, cancel out, and that's exactly what should happen. The second column, x minus a negative 5, becomes x plus 5x, or 6x. Bring down that next term, negative 30, and do it again. Determine what you need to multiply x by in order to get 6x. And of course you have to multiply it by positive 6, so that goes above the 30. Your column of degree 0, and multiply through by it. 6 times the x minus 5 out in front gives us 6x minus 30. When we subtract, of course the first columns cancel out, and in this case the second column does as well. So we're left with 0. We do not have any terms to bring down, so which means it divided in evenly. We have a remainder of 0, so our final answer, x plus 6. Example 4. Dividing by a polynomial with more than one term, primarily a binomial, we have to use long division again, so that x plus 7 goes out in front. Inside, we begin with the term with the largest degree. That x cubed has a degree of 3. But the next term must have a degree of 2. Well, we don't have a term in the numerator of degree 2, so we're going to have to put a placeholder in. Our placeholder is going to be 0x squared. X squared, so degree of 2, but 0 times anything is still 0, so we're not changing the value, we're just changing the way it looks, a placeholder. Same thing now, the next term must have a degree of 1. We don't have a term of degree 1 in our numerator, so we're going to put in another placeholder, 0x. And the last term must have a degree of 0. Well, that's our 343. So we have to have terms for each descending degree all the way down to 0. Degree 3, degree 2, degree 1, degree 0. Now it's time to divide. Determine what you have to multiply x by to get the first term here, x cubed. And you have to multiply x by x squared to get x cubed. Multiply it by the x plus 7. It gives us x cubed plus 7x squared. And subtract. The first columns cancel out, exactly what you wanted, leaving us 0 minus 7x squared, or negative 7x squared. Bring down the next term, that plus 0x, and do it again. We need to multiply x by a negative 7x in order to get negative 7x squared, so that goes above the 0x. Multiply it by the x plus 7 out in front, negative 7x times x, negative 7x squared, negative 7x times 7, negative 49x. And subtract. The first column should cancel out. They do. 0 minus a negative 49x becomes a positive 49x. Bring down the next term, positive 343, and do it again. Determine what you need to multiply x by in order to get 49x. You need to multiply it by 49, so that goes up and top. Multiply it by the x plus 7. It gives us 49x plus 343. Subtract. The first columns cancel out, and once again the second columns cancel out, leaving us a remainder of 0. So our final answer, x squared minus 7x plus 49. And example 5. Dividing by a binomial, so long division. Set it up. 7x plus 2 goes out in front. The numerator, the largest degree is 2, so 14x squared. The next term must have a degree of 1. Well, that's our negative 3x, and the last term must have a degree of 0, negative 39. So in this case, we did not have any placeholders. Go ahead and divide and determine what you have to multiply 7x by to get 14x squared. We have to multiply it by 2x, so that goes above the negative 3x. Multiply it by the 7x plus 2. It gives us 14x squared plus 4x. And subtract. The first columns cancel out, leaving us negative 3x minus 4x, or negative 7x. Bring down the negative 39 and do it again. We need to multiply 7x by a negative 1 in order to get this negative 7x, so multiply through. Negative 7x minus 2. Subtract. The first columns cancel out, but the second column does not. Negative 39 minus a negative 2 leaves us a negative 37. Since we do not have any more terms to bring down, this is our remainder. And the way we would write a remainder is plus the remainder, negative 37, over what you're dividing by, 7x plus 2 in this case. Which we would, of course, neaten that up as 2x minus 1, simply minus 37 over 7x plus 2.